Hello everyone, my name is Faye, and in this particular video, we're going to learn about binary search. Okay, binary search. Okay, so the basic concept of this search that you guys need to know that it is only can be applied to sorted array. So after the array is already sorted, whether it's ascending or descending, right there when you can do your binary search. Okay, so what binary search do is divide the array into two parts, and you will search according to the information that you already divided to the left and the right parts. Okay, so to understand this, as usual, the best part is to do visualization about binary search. So let's take an example that we need to find 405. Okay, what binary search do is it will divide, okay, left, right, left, right, and you take your middle. This is your middle, okay, okay, okay. So that's for the complete visualization. Let me explain to you part by part. Okay, so first you have your first and the last index, which is 0 and 31. And you need to find the middle value, the middle index value. This is the common mistake of people doing searching, sorting, and everything. What we do, we operate with our index and we compare with our index value. So what you do is you find the first and the last index, 0 and 31. To find the middle, what will you do is 0, the first and the last index. You sum it, and what you do is divide it by 2, and you get the middle. Okay, 31 divide by 2 will get 15. And 15 is your middle right now. What we search is 405. Okay, so if our middle is right here, okay, our and its value is 430, this array is already sorted ascending. What we want to find is 405. Okay, because 405 is smaller than 430, we didn't need to find the right side of our middle index, right? We only need to find on the left side. So what happened? The middle will become the right now, okay? The left stay on the 0 index, and our mid will become our right index. And we repeat the same steps. Okay, so what we do here, as you can see, okay, our middle will become our right index. Why is it not on 15? Is it on 14? Because what we do, we already compare the middle index. So what we do is minus our right index right now, which is 15 by 1, and we get 14. You can still get the answer by not minusing it with 1, but our basic concept minus it with 1, because we didn't need to compare thing twice. Okay, that's it. Okay, right now we have our new middle is on index 7, 323. What we want to find is 405. Our 405 is bigger than 323, so it will searching on the right part. Okay, the left part of the middle is smaller, so we didn't need to find there. Okay, index will become 8. Right now, the left index is the one who changes, and after that we have our left index, our right index. After that, we divide it by 2 to get the middle index. What we want to find is 405, which is the value is higher than 372. We find on the right index, and this is what you get. Okay, and it will do it until the end. Okay, and we find it on index 14. That's what binary search do. Okay, same as here. I think the best visualization is what we find before, and that's for binary search. And the code to understand it. This is the code to understand it. Okay, so um, example, you have R of num right there. Okay, search for target in a sorted array. This is what you need to do. If found, it returns the index of target. Otherwise, it returns -1. So -1 is something that you didn't have in array. Array doesn't have negative index. So if it's -1, then yeah, you didn't find it. Okay, so this is the code. Like what I say, we always need to find the middle first. Okay, mid is left plus right divided by 2. If it's the same, then you return the mid. If the middle is lower than the target, our mid plus 1 became the left. Okay, so that's how you do binary search. Okay, so for searching, that's all for searching. And for exercise to understand binary and sequential search, it's literally the thing that you always change is just your target and your comparison. Okay, this your if will always change. Okay, so in an example, you have a struct. Maybe you want to compare the value and armit val something like that. If you have array of struct, that's what you do. Armit dot value, or maybe if you want to find in a range of age, what you do is armit dot age, something like that. So for searching and sorting, just learn about the algorithm, okay? And the implementation is almost the same, okay? You just need to compare, the comparison is the one who changes, okay? That's all. Thank you.